Machine learning or artificial intelligence is about prediction, using information that you have to generate information you don't have.
Artificial intelligence, machine learning, deep learning, we can have a lot of semantic conversations about where does the specific technology lie, but essentially it's transforming how we create and what we create.
When we talk about artificial intelligence, very often our imagination goes to YouTube videos of humanoid robot, snake-like robot, maybe dinosaur-shaped robot, dog-shaped robot, or robot coming in all sorts of shapes and form.
Artificial intelligence, including machine and deep learning algorithms, have inspired many novel computational methods for the selection of candidates with high affinity and specificity.
So all of those AI technology are really coming together and are come of age to actually really transform the way human and machines are actually interacting with each other. I think we're moving from you having to learn the machine to actually the machine, learning you.
There are quite a few ways to define what is artificial intelligence, and you are going to have people say that if it works, it's no longer AI. AI is just the new things that don't really work. Especially in there has been a few hypes of excitement in artificial intelligence, and as a result, in the past, AI had gotten a bit of a bad name.
At the end of the day, technology is here to really amplify human-centered experiences.
People tend to conclude too early that they can understand it.
When I began writing about it 10 years ago, we were still dealing with I would say science fiction concepts that a lot of people might consider as too far out. But because of technology, because of improvements, because of the evolution of the microprocessor, what's happened is we've gone kind of from science fiction to a world where artificial intelligence is becoming something that's very significant in our world, something that's already starting to change things, something we're coming across in computers, and of course something we're coming across in pharmaceutical companies as they're trying to develop new drugs just based on using AI. So the future of AI has sort of arrived.
The biggest threat is not AI for humanity in a singularity scenario, which is rather part of these science fiction scenarios. The biggest threat for humanity is us humans, right? We are creating these big challenges which we have to tackle, like climate change, but not only climate change.
There's the scientific side, and then there's the science fiction side. But what's the benefit for all of us? To me, it's all about the ability to see patterns in more data and make predictions beyond what we humans are capable of, and we're just limited to time and resources.
But in the end, it's a matter of understanding, as Kai also mentioned. The more we understand of this, the more secure we'll feel.
The question about being afraid of AI dates back to 1956. So it's not something new. I mean, things have been going on and on in years. And I think the big issue today is not about AI. It's about the type of algorithm that we're using within it, which is a subset of AI, which is called deep neural networks, which are data-driven based.
There are a lot of challenges these days in implementation of AI.
In the past several years, along with this acceleration in commercialization, the development process of artificial intelligence has actually experienced a huge change.
What are the largest barriers against the AI adoption? It is important because we think that if we don't see the barriers, then we cannot overcome the limitation or cannot make the workarounds.
AI powering economies, powering businesses is actually like electricity, which was a huge transformational trend a century ago.
No doubt AI has now already been used for a long time in forecasting energy demands and managing essentially the consumption. Managing power grids.
You will get data in all forms and shapes. There will be images, there will be videos, there will be a bunch of text documents, diagrams, et cetera. So you need AI to be able to process and break that down into being able to analyze it. That's where AI comes in.
In the United States alone, there is 11 million people, or the entire population of Los Angeles and New York, that cannot leave their homes without some sort of assistive device. And 3.5 million people, just like my grandmother, could not leave their homes at all. And beyond just the leaving the homes, lots of people cannot interact with the technology because the digits are small, the finger dexterity is not great. So there is a huge opportunity in improving quality of life for lots of people and making for the rest of us more convenient if we can have robots or bots, digital bots, that can complete mundane tasks for us.
Earth is now surrounded by high quality satellite and sensor network that can provide detailed feedback on current conditions. We can detect and track wildfires, tropical storms, natural disasters. We can improve search and rescue and detect harmful greenhouse gas emissions. Observations are also really critical to weather forecasting.
AI can really help in many places, and it's been proven that AI can reduce carbon emission by 20%. If you just do a digitalization process, digitalize your operation, you're going to reduce your emission by 20%.
To use the next step of technology, which is basically the use of AI in controlling the vehicle and the electrification of the powertrain to promote better racing series from micromobility to very fast cars.
We want to find new drugs for either existing diseases or new diseases. And of course, we're all familiar with the COVID story and how it took a major effort to find the appropriate vaccine for it. And here we find numerous AI tools around modeling the molecular processes about protein folding, analyzing root causes, and so on that help.
The differences are not that huge as before. You can observe very different shapes, very different sizes, but for this case, they are not that obvious. So it's not that easy to distinguish bacteria based on the spectra. And what Quanta did, we prepared a software to identify species or even strains of bacteria.
A great application that my team has recently launched, where we taught Alexa to read books with kids, which I find is a super sci-fi thing. Alexa talks to your kid and asks him or her to read a book. The kid reads the book, and then if there are any mistakes, Alexa with automatic speech recognition identifies it and corrects the kid, and then reads book with him or her, like a robot that is actually playing with you.
We believe, at least, that an AI code of ethics is really the cornerstone of what we think of as trustworthy AI.
My concern, especially when it comes to AI ethics, is that the technology is going to evolve much faster than the pace at which society is evolving, right? So we need an evolution, not just in terms of how we innovate at the technology level. Of course, that's already happening. We know that because there's a lot of incentives, both at the low level as well as the high level, right? You see it in the public sector and the private sector. But what we need is also reform in how we think, in our educational policies, in our ethical body building, in the regulations and laws. So we need to kind of ensure that those are not left behind.
First of all, we define the problem. So there's a problem definition phase. That's very important. The next step is to start collecting data and gathering the data we need to solve this problem. And then, of course, we have to explore the data. We have to find the patterns in this data. We have to prepare and clean the data. And then we move on to the model exploration and model training phases, where basically we are, training different algorithms. We are trying to figure out which is the best model for our case.
As we heard, the breakthroughs in AI really makes it possible to leave the one-size-fits-all training models. And that's what excites us the most at Sana Labs.
Violet AI detects potential assembly issues and offers immediate assistance to operators through visual cues and targeted training videos. ensuring that each action is completed as per the standard operating procedure.
Come on, let's bake this synchronization into the language. Let's make it correct by design. Let's provide the tools for designers so that they cannot make mistakes.
We are integrating AI into industries, research, and everyday life. Because in industry, the AI is transforming the industry with this kind of smart capabilities. For example, smart manufacturing, the smart cities, and also in research. Recently, we are excited to see a lot of research innovations based on AI.
Another application of video analytics and Azure Video Analytics solution in particular is quality inspection. This is a real project, a real picture from Poland, where the organization which produces pills, the pharmacy producer, they actually look at the pills which are going on the line, and you can see, for me, they all look very similar. But for the computer vision model, it can identify the pills which have some defects, which should not make it to the final product. And that's actually a very powerful solution.
So Earthbank is a climate fintech and a space tech firm which enables individuals and organizations to offset their carbon footprint with AI-driven satellite metrics and to make better financial and climate mitigation decisions.
But essentially we're using Flower to generate traces of energy usage under various kinds of federated learning settings. And then we combine that with a carbon model that allows us to translate this energy consumption into carbon based on assumptions of where the devices are.
Deloitte reports that 75% of enterprises said that AI would transform their organization in the next 3 years.
More than 79% of the business leaders have either promising proof of concepts, and in some cases, they have actually deployed AI models in a large scale.
DCAI, Datacentric Artificial Intelligence, this idea that we really need to be putting a lot more work into the tooling and the development of the data. Because for so long, everybody in our industry was focusing on sexy, cool, fun new models, like adding another layer to the neural network, adding a feedback loop, all of these different things.
If you think about it, graph data is everywhere. Like pretty much any field you are in, you will have, and you might have encountered some graph data. For example, social network is an obvious graph data.
Repetitive and processing types of jobs will disappear. So new employees will land in a world when their value will be based on their capability to interact with and supervise AI-powered systems and design new data and AI products and services.
So we want to be able to find exploits in games and bugs before the players do. Also, another advantage with RL is that it doesn't have to be scripted. You can train us that. So meaning that also people at EA who cannot script could maybe start to use this technology as well.
This entire thing here is produced from a no-code software. So you don't actually, all of the tools here can be clicked together by any user. And here these are sort of race engineers and drivers who don't actually understand software programming. So the dashboard that you're looking at here doesn't require any coding experience. It doesn't require any machine learning AI or physical simulation experience.
Swarm AI at the highest level can be described as follows. You start with a networked human group. Those people could be anywhere in the world, could be 10 people, could be 2,000 people. The important part is that this group of people has knowledge and wisdom and insight and experience about some topic. You're going to connect those people together with AI algorithms that are modeled on swarms in nature, and you're going to turn them into an artificial expert that you can then ask questions to and generate significantly more accurate forecasts, estimations, assessments, decisions, predictions, insights.
I am noticing the trends emerge in the web development, the coding, that we are using more and more tools that have some kind of AI models built into them. For example, recently, Microsoft and GitHub, they released a tool that helps you code. So they parsed all the code that's open source on GitHub, and they try to generate
to figure out what you are trying to say while you write the code. And that's very interesting.
What we really try to wrap our heads around, be that when we speak to seed companies, because we decide, pretty much at seed whether we want to, continue actively to active track the company, is what does AI bring, and whether that is going to be something long-term sustainable, and how much effort we'll have to go there to use the power of AI to bring more value.
There are really two things as to why we do invest in AI. One is obviously it's transformational. It will impact, and it has been doing so, everything that we do day to day. And also it is supposed to tackle some of the big problems that humanity is facing today, and it will do in the future. So we would love to be part of that effort.
Building AI project, implementing AI is not cheap. It usually starts with hundreds of thousands of dollars to have full AI implementation. And if it turns out that you also need to build a large new system around AI, it can go into millions easily.
Today, the product is typically best when it leaves the factory. But with machine learning and AI, it can actually become better and better the longer you use it, to be optimized for a particular use case and not a general use case, which is really the reality today.
Product managers, product leaders need that experience designing actual applications that customers would use, not just the algorithms behind the scenes, but something that you can put in front of customers that they can actually use.
Being able to give them an environment where they feel safe. The words that one of the young ladies used, the 13-year-old Kishan, said, being able to code and to put together a robot makes me feel brave.